Hi everyone, this is the introduction to Gauss law chapter. We will see some concept that we need to understand in order to solve problem related to Gauss law. The first concept I want to talk about is how the charge are distributed on a conducting surface and on a non-conducting surface. So let's look at the diagram over here. We have conductor, an insulator, or non-conducting object. So you can imagine, let's say we have a metal sphere. You add some electron on the middle sphere. Well, in a conductor, the charge are free to move. Therefore, if you place, let's say, two electrons, they will go as far away as possible from each other. Now remember, similar charge repel each other, and since they're free to move, they will go as far as possible. So on a conductor, the charge will all go on the surface as far away as possible from each other. Now, this has an interesting consequence. Well, first, all the charge are around the surface, and also that means the electric field inside the sphere is equal to zero. Now, to prove that the electric field is equal to zero, we need advanced calculus. I'm not gonna do that derivation. Just take my word for it. So if you are ever asked in a test, what is the electric field inside a conductor? It is always zero, all right? Now, one of the type of problem we're going to solve later on using Gauss law is to talk about the electric field inside a non-conducting object. Now, if a non-conducting object is charged, since the charge don't move easily inside, it is possible for that object to have an even charge distribution. In other words, they can be charged in the middle, a bit spread everywhere. Now, you will see in this course, we are going to deal only with charge distribution that is evenly distributed. So that means there's the number of charge per volume unit is the same throughout the object, okay? We will see many examples just to explain that concept. The second concept we need to talk about is the concept of a point charge. Now, since the beginning of the course, all we've been doing relating to electric field and the Coulomb force is to calculate the force between 2-point charge. We did not yet calculate the effect of a charge distribution on an object. And as you will see, we need tricks like Gauss law to do these type of calculation. That's why we avoided them until now. But one thing we need to talk about is, let's say we have a sphere, a charged sphere. Mathematically, what we can do is take that charged object and replace it by a dot at the center of the object, and both object, the dot or the point charge, and the charge object has the same charge. Mathematically, it is the same. In reality, the effect is the same. These two are not physically the same. It's only their effect that are the same, all right? So when you have a sphere or an object that has the shape of a sphere, we can replace it by a dot, a point charge located at the center. Now note, this concept is only useful if you want to calculate the electric field outside the object. If this is a conducting sphere and you want to know the electric field inside, well, it is zero, all right? If it's not a conducting object, like this one, we would need to use Gauss law. This concept is only useful when you want to calculate the electric field outside such an object. All right, so that's it for the first video. In the next video, we are going to introduce the concept of electric flux. All right, so see you there.